Have you ever really thought about where you came from? And I don't mean how were you born or how did you get to the city where you live. No, I mean your body, this stuff, the matter. How did it get here? How were the chemical elements created? Now, making new chemical elements is not an easy task. It takes unimaginable heat and pressure, the likes of which we can't sustain here on Earth for any length of time. So we'll have to rely on nature's refinery. And those are the cores of giant stars. Now, in the core of a giant star, the temperature is in the millions of degrees, and it's 10 times as dense as lead. Under these conditions, we can actually fuse together lighter elements to make heavier ones. 4 hydrogen can go to 1 helium, and 3 helium to 1 carbon, and on all the way up to iron. But here's where the process stalls. No matter how big or bright or hot the star gets, you just can't get past iron. So this big ball of iron develops in the middle of the star. But what about all the other elements, like potassium and lead and uranium? To get those, we have to rely on the most violent process in the universe, and that's a supernova. In a supernova, this big ball of iron keeps growing and growing, and the pressure from gravity just stronger and stronger until it collapses, mashing the iron down into itself. And here's where things start to get a little bit weird. Under these pressures, the iron forms this dense nuclear goo stuff. Some types we call nuclear pasta. You can make these long, thin strands. That's the spaghetti phase. And if these strands fuse together under even higher pressures, that's the lasagna phase. So this weird nuclear goo is developed in the very core. But the rest of this ball of iron is now a void, so the rest of the star rushes in to fill the hole, bounces off the goo in the core, and sends a ripple, a shock wave, through the rest of the star. And it's in the next few minutes, as this travels through the guts of the star, that all the other elements are made. And then, blown off into space. And we can still see the pieces from that today. That's the gold and copper in your cell phone, or the calcium that's in your bones. And that's what I study as a nuclear scientist in the laboratory, so we understand how all this stuff got to be here where it is today. So, the next time you pick up something metallic, remember, you're just borrowing the dying burp of a star as it digested some nuclear pasta.